and welcome back. In this video, we're going to work through an example of how we find vertex form of a quadratic function by looking at its graph. So let's find a formula for the quadratic function graphed below. Here I have the graph of a parabola. Let's call the function k, and I've already identified 2 points for us that we're going to use. So what I notice here is that there's a very clear vertex, and so I can use vertex form in order to write the formula for the quadratic function. So I see the vertex is at -4, -5, and this will help us use our h and our k in our vertex form. So specifically, we're going to do k of x is equal to a times x minus h quantity squared plus k. And just from the graph, we already have h and k, so we're making great progress. So h is -4, and k is -5. When I write this out, I have a times x minus -4 quantity squared plus a -5. So this can get kind of messy with all the negatives, so I always like to take another step and simplify them. So x minus -4 becomes x plus 4, and then plus a -5 is just -5. So I rewrite this as a times x plus 4 quantity squared minus 5. Now we're actually super close, but we still need to find our leading coefficient a. We're almost done writing our formula, but we're missing a. I'm noting that the parabola opens upward, and so we are expecting to have a positive leading coefficient since it opens upward, so our a value will be greater than 0. And I'm going to keep that in mind as I do the math to find a. So our general technique anytime we need to find the leading coefficient of a quadratic is to choose another point on the graph. So I'm going to pick a point that I can see. Here I've already identified one for us. It's 0, 3. But you could pick another point. So you could pick like -8, 3 if you wanted. But we're going to use 0, 3. So our plan is to substitute in this point that we know. We can see this point on the parabola. And we're going to substitute it into our equation and solve for a. So we're going to replace our output and our input with this point, and then we'll have one unknown that we can solve for, that unknown being a. Let me show you what this looks like. So we have k of x equals a times x plus 4 squared minus 5. And we want to find a, so what I'm going to do is choose our point 0, 3 and substitute it in. So 0 is an x value, and 3 is a k of x or a y value. So I replace k of x with 3, and x with 0. And we're going to then solve for a once we've done that. So I write the equation 3 equals a times 0 plus 4 squared minus 5. And you can see here, once we've substituted in this point, the only variable we have left is a. So we've gotten rid of the k of x, we've gotten rid of the x, and all we have left is a. And from this, we can solve for a. All right, so just now we do the math in order to solve for a. I'm seeing that 0 plus 4 is just 4. So I have 3 equals a times 4 squared minus 5. Then I'm going to add the 5 over to the left-hand side. So I have 3 plus 5 equals a times 16, since 4 times 4, or 4 squared, is 16. Now I just keep simplifying. So 3 plus 5 is 8. And then 8 will be equal to 16a. And we just want to isolate for a. We're so close. So in order to get a by itself, I'm going to divide both sides by 16. So I have 8 over 16 equals 16 over 16 times a. So dividing by 16 makes it so that we just have a 1 on the right-hand side. So we have just a. A is equal to 8 over 16, which is the same as 1/2. So our a value here is 1/2. And now we can write our final answer. So we had our form, we just needed to know what a was, and so we can substitute it in now. We say k of x is equal to 1/2 times x plus 4 quantity squared minus 5. And there we go. Okay, so just to review our process, we started with the graph. We could easily identify the vertex, so we used vertex form to substitute in h and k. Then we plugged in another point, we substituted in the x and the k of x value, and solved for a to find that leading coefficient. Then we rewrote everything as our final answer. So anytime you're trying to write an equation of a quadratic function, you can use this process, as long as you have the vertex and you're using vertex form. Alright, that's it for this video. Thanks so much for watching, and I will talk to you in the next one.